Ladies and gentlemen, finally, our practice set for labs G and H. It's just 3 questions, but it gets to the heart of the matter of what's on those slides. So let's do the first one. Given 100 rows of training data where you will do a sevenfold cross validation test, how many numbers will you have in each set? Okay? So hypothetically, let's do it like this. I have 100 rows and I want to do a 7K fold test. That means I got to create 7 groups, right? So I'll just say K1. Let me make this a little bigger so you can see it. K1, K2, K3, K4, then we're in a space, K5, no problem, K6, and K7. K7, all right, slightly smaller. Slightly bigger, now you can see, all right, cool. All right, so I'm gonna have 7 sets, broken up K sets. Now I have 100 rows. Now I need to divvy it up in these 7 sets. Remember, what's the formula? It's very simple. It's basically gonna be 7 divided by 100, right? Which gives me a value of 14 with the remainder of 2. All right, the remainder of 2. So what that means is I use both these numbers to figure out, I mean, it's actually common sense, but it's actually common sense how you would do it. But I mean, if you want a quantitative way to figure it out. So my first 2 Ks will have 1 plus whatever this value is. In this case, 14, so it'll be 15. So this will be 15, 15. And then the remaining will have 14. All right, for a sum of 100. So that's basically how it's done when you have, again, rows that don't evenly divide into your different Ks. It's okay. This is basically the formula they use. All right, so that's our number 1. That was fairly easy. Now, number 2 takes slightly more time. Right, given the training data below, already randomized, and assuming you're doing a 3-fold cross validation test, 3-fold, kept it simple, what is the X error and X STD? All right, so here's my table. Can I copy this? Did I copy this? Oh, I wish I had that in here. So let's do this. So I could copy it real quick. All right, number 2. All right, so we have a fruit column, sugar dot level column, and a peel dot width column. All right. So fruit is apple, orange, cherry, orange, apple, orange, cherry, orange, apple, cherry, orange, apple, and a cherry. And the sugar level is going to be 2.1, 1.8, 2.7, 1.7, 2, 1.5, 1.6, 2, 1.5, 1.9, 2. Just copy. I'm basically copying this, so I can just do copy and paste. 0.2, 0.4, 0.2, 0.9, 0.8. Oops. 0.4, 0.2, 0.8. Why am I confused? 0.8, 0.1. There we go. 0.4, 0.8, 0.9, 0.5, 0.7. Alrighty, finally, I got it. Now, let's go ahead and do our threefold test. Okay, I already have this randomized, so I'm just going to create my three folds. Now I have total amount of rows is 11. So, I mean, we could apply the same formula again. 11 divided by 3 gives me the answer 3, so that'll be right. And with the remainder of 2. Okay, 3 divided 11 is going to give me 3, remainder 2. So that means my first K will have 4 values. I'm just going to highlight the formula. I'm just going to color this different color. All right. My second one, remember, it's 2. So there's 2 of them that's going to be 4. I'm going to make this a separate color. I will call you green. And the remaining one will be 3. And they will be a nice magenta. All right. Or should I do orange? Yeah, orange is probably easier to see. Bam. All right. So I have my K1, K2, K3. All right. Blue is K1, green is K2, orange is K3. Done. All right. So let's go ahead and get to work. The first one I'm going to do is my first training data will be blue and green. Let's do it by test data. All right. To keep things easy. All right. So what I'll do is my first test data will be blue. All right. Test data blue is my first thing. So the first one, test data blue. What that means is my training data will now be green and orange. All right, it will now be green and orange. So the first thing I need to do is I need to sort these values. Ideally, what you should do is you sort the values according to the different columns you're doing, create the different groups, and go from there. I'm going to just cheat a little bit to move a little bit faster. All right, so yeah. What I didn't tell you is, to make things easier, we should do a min bucket of, let's do a min bucket of 3. I'll add that into the questions after I'm done with this video. So let's make it a min bucket of 3, just to make things calculations move faster. Just so we have to do less calculations. Or am I cheating that way? I feel like I'm cheating that way. All right, let's just do min bucket 1. All right, let's just do min bucket 1. All right, so if I sort these values, oops. Oh, do I have to sort it? Nah, I have to sort it. All right, so let's start with the first one, right? What's my min? 1.5. Okay, it goes from 1.5, 1.6. So what are my unique values, right, guys? First of all, let's give them all my unique values. 1.5, 1.6. Oops. I'm just sorting it for the first step, guys. Um, 1.5, a 2 already got. I mean, no, I didn't get, so let me give it 2. 1.5 I already got. 1.9 and 2. All right, so not bad. All right, that's why I didn't give a min bucket, because I knew it was going to be the situation. All right, so let's leave it. No min bucket. All right, so first off, we can't use 1.5 and 2 because we're going to have leaves that are empty, right? So honestly, the only viable numbers we can choose from is 1.6 and 1.9 here at this point. 1.6 and 1.9. All right, so let's go ahead and do that. For 1.6, less than, I'll do this side will be the less than. Let me just write it. Less, or actually, I'll just get the symbol. And is that less than? All right, I guess it is. And this will be greater than or equal to. Actually, it should be this, sorry. And this should be greater than or equal to. There we go. All right. So less than 1.6, all right, which values are less than 1.6? It's basically this one. It's all basically all the 1.5s, right? So then now I have basically apple and cherry. All right, I got apple and cherry. Greater than 1.6 is going to give me, greater than or equal 1.6 is going to give me everybody else. So that's going to give me cherry, orange, cherry, orange, apple, apple, and cherry. All right. So now that I do the Gini score, I can go ahead and calculate the Gini score for these guys. It's going to be basically equals 1. Let's go ahead and put it up here. Equals 1 minus 1 divided by 2 squared minus 1 divided by 2 squared. All right, and we get a 0.5. All right, excellent. The next value that we can do is going to be, I think the only thing left was 1.9. All right, 1.9, it's going to be less than, greater than or equal to. All right, so less than 1.9 is what? It's going to give me 1.5, cherry. Less than 1.9 is cherry, orange, cherry, orange. I got my cherry, orange, apple. Not this apple, because that's 1.9. We want less than 1.9. So now we're done. Everything else will go here. So that will be cherry, greater than or equal 1.9. Apple, apple, and cherry. All right. Oh, I'm sorry. I did the math wrong here. Let's go back. Why did I do 1/2 1 squared? That's wrong. Sorry, I'm sorry. We're not done. I don't know. I totally skipped to 1.6, so I jumped on it too fast. This will be, move this down here. I'm sure some of you guys are wondering, like, wait, Professor, jumped the gun. Yes, I did. I don't know. All right. So for this column, it's 0.5. Let me move this over here. All right. I didn't do the Gini score for that. And then we have to do the combined Gini score, and that's what I'll put up here. All right, for this one. Because remember, this is the left node, and this is the right node. Okay, this is the left node, apple cherry, the left node. These values are the right node. I got the Gini score for the left node. I gotta do it for the right node, and then take the average and do it for 1.6. Come on, wake up. All right, so for this guy, it's going to be 1 minus. There's only 2 cherries, 1, 2, 3, 4, 5 values. So 2 cherries will be 2 divided by 5. Square that. Subtract. There's only 1 orange, so that's 1 divided by 5. Square that. And finally, apple, there's 2 of them, so that'll be also 2 divided by 5. And I will square that. Okay, now I got a 0.64 for the right node. Now remember, the Gini score for both of them is going to be the weighted scale. All right. So altogether, there are in my K test data, there's 1, 2, 3, 4, 5, 6, 7 items. The first one has 2 of 7. So 2 divided by 7 times 0.5 plus 1, 2, 3, 4, 5. 5 divided by 7 times 0.64. And that's my total weighted Gini score. Excellent. 0.6. Excellent. All right, come back here. Let's do this right. My Gini score here will be cherry orange apple. Wow, 1/3, 1/3, 1/3. All right. It'll be 1 minus 1 divided by 3 squared minus 1 divided by 3 squared minus 1 divided by 3 squared. Well, you should never have an equal, I mean a negative number. So I have made a mistake somewhere. Oh, this is where I'm put a squared over there. And this should be okay. Excellent. 0.6666, whatever that is. All right, and now I'm going to do this one, and this one will be basically, I'm going to just copy this one over and tweak it. So 1 divided by, oh, okay, no. What I should do is basically going to be, this is going to be 2 divided by 4 minus 2 divided by 4, which is basically this right here. So I can just put a 0.5 in here, guys, right? Because this becomes 1/2 squared. It becomes like the same equation here, because this becomes 2 over 4 squared minus 2 over 4 squared, which is 1/2 squared, 1/2 squared. It was basically the same thing here. So we know this is 0.5. Alrighty. So now I'm going to do the Gini score here. And this will be 3 divided by 7. Times that plus 4 divided by 7. All right, boom. So I got my Gini scores. All right. So from here, all right, guys, from here, what is the, so look, technically we're supposed to do the other column too, right, guys, and find, we tested this, the first column, basically the sugar.level column, and they're supposed to do the peel.width column. But for the sake of time, we can ignore checking the second column. We'll just assume the best values come from the sugar.level column, right? Obviously, in the test, you have to check both columns. I won't make you check both columns, right? I'll figure out a shortcut way so you don't have to do it all. But just for the sake of time, right? So let's assume that we're just doing it for one. Let's just say there's what we know that the sugar dot level will have the best values, right? Hypothetically. So in this case, which one is a smaller? Which gives us a smaller Gini score, guys? It's this one. So it's 1.9. So we're going to split based on 1.9. We're going to split based on what 1.9 is. And so if I split based on 1.9, right? I split based on 1.9. Now I go to my first k-test. So blue is my first test. And I'm saying, okay, less than 1.9 is going to be the left node. Greater than or equal to 1.9 is the right node. So what's my predictions, right? So when I do that to my, when I build my model with my training data, here we have a slight problem in the sense that we just have cherry, orange, apple, right? Here we also have cherry, apple, orange, right? So the problem here is that, oh God, which prediction do we do? This data set is actually quite, is not very helpful in the sense that they're both relatively equal, which sucks, right? So, but in terms of distribution, all right, see, neither one is a clear winner here on the right or the left side. So unfortunately, I didn't make the data. Unfortunately, I didn't make the data as unique as it should have been, right? So, I mean, see, the way it works is now we choose 1.9. The model we're going to create is basically whatever is the majority here. When we do less 0.9, whatever the majority here, that's what the prediction will be. Whatever is greater than or equal here, that's what the prediction is. I mean, this is a natural result of the fact that we're just using too little data. We're using too little data. Now, again, I'm going to cheat here a little bit. I'm going to assume, let's say, in our data set here, 1, 2, 1, 2. There's 3 cherries, 3 apples. This one didn't work out too well. All right, so for argument's sake, let's just take it alphabetically, I guess. Let's just choose one for the other and the other one for other. So let's assume that this left side would have had more cherry. So less than 1.9 will be cherry. And let's assume this side had more apple, hypothetically. And 1.9 has, so greater than or equal to 1.9 will be apple. All right, so that's how the model will deduce the model. All right, guys, again, I'm sorry about this. I wish it was a cleaner example. But let's just assume there was more cherry on the left node and more apple on the right. I'm sorry. What did I say? Yeah. More cherry on the left node, more apple on the right node. So if it's less than 1.9, if the fruit sugar level is less than 1.9, we predict cherry. If it's greater than or equal to 1.9, we predict apple. All right. So that's our model. Now we go back to our test data. All right, we look at sugar dot level. So we're making 2 cheats here. One, we're not looking at the petal width for Gini scores because remember, petal width would be better. And 2, we didn't have a clean prediction one way or the other, so I'm just making it up at this point just so we can continue with the example. Right, I'll be for the exam. I'll try to choose better data set that gives you cleaner answers. So here now look at the sugar dot level. So remember, greater than equal to 1.9 is an apple. All right, so I'm looking at the sugar levels. These are the actual values of my test data. Now I gotta do the prediction, all right? So let me just grab the actual. And the prediction is going to be 2.1, that's apple. 1.8, that's less than 1.9, that's cherry. 2.7, that is greater than 1.9, that is apple. And 1.7 is less than 1.9, and now we predict that to be cherry. All right. So now we have our prediction and our actuals, and now I'm going to create the confusion matrix, right? Because remember, we need to get the relative error. So I mean, by now you guys know that everything's alphabetical. So this will be apple, cherry, orange, my actual values. And this will be my apple, cherry. And again, I apologize for how it's not that clean, but we're just using less data. And, you know, this is the risk you run when you use less data, but I wanted you guys to work this by hand so you guys can see this a little bit better. All right, so in terms of our actual values, right? So we have one apple, and it was misrepresented as cherry. All right, so this is 0. This is 0. We have one cherry, and that was done correctly. Excellent. And we have one orange, and that was misclassified as apple, right? And this is our confusion matrix. It's very, 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 very skinny, right? And so now we want to get the error rate, and then we want to adjust it. So what's our error rate here, guys? So what's our error rate? Our error rate is going to be whatever is not on the diagonal. So that's this one and this one divided by the total amount of numbers. So our error rate in this case, guys, is 2 divided by 3. 2/3. All right, and now to get our relative error, we want to divide this number by what? By the original error in our data training set. And in our data training set, the way we get that original error, or what we call the baseline error or the root error, we look at the total amount of values. We see what the largest number is. So we have 1, 2, 3 cherries, 3. Oh my God, it's the same problem again. Ugh. All right, so we had 3 cherries, 3 apples, and I'm going to choose the one that's just the most out of all of it. So I believe there's more apples than cherries. So I'm going to say apple. All right, I'm going to say apple. This is an apple one. All right, 3 cherries, 3 apples, 1 orange. So I'm just going to say it's apple. All right, again, apologize for not a clean answer. So let's assume it's apple. So the amount of errors is 1, 2, 3, 4. 4 out of 7 is the error. All right, 4 out of 7. So I have to divide my error rate by my relative error. Let's start. I'm sorry. Let's call this the root error first, which is 4 divided by 7. Right, and so now my relative error here is going to be the error rate divided by the root error. 2/3 divided by 4/7. Is there a clean way to do this? No. So let's just do 2 divided by 3 divided by 4 divided by 7. And our relative error is 1.116. Yeah, you can get that. That's fine. Right? The one relative error being greater than 1, that happens from time to time. All right? So in this case, we have a total mess. So just go with it. So that's our relative error. And cool. We just knocked out, even after all the cheating we did, that was round 1. Now we're going to do round 2. Remember, there's going to be 3 rounds altogether. In round 2, our test data is going to be, let me just copy this. So we keep having it as we scroll down. It's just easier that way. And in round 2, we're now going to do, green is our test data. All right, green is our test data. All right, so green is our test data. And that means our training data is the blue and orange. The blue and orange. And again, let's go ahead and get the unique values from blue and orange. I believe the smallest number is, again, 1.5. For sugar level, again, we're just cheating, and we're not gonna include PL.width, but technically you do. All the columns are taken into account. 1.5. The next one is 1.7. Number 1 is 1.8. Let's see, did I get them all? 1.9. I'll be a much bigger distribution here. Two, 2.1. Okay, wow. And 2.1, and 2.7. Alrighty. We got a lot more work to do for this one, guys. Sorry. All right, 1.5, 1 point, there's no 1.6, 1.7, 1.8, 1.9, 2, 2.1, good lord, and 2.7. All right, so 1.5 and 2.7 are out because they'll just give us 0 and 0 values for one of our nodes. We'll start with 1.7. So we'll do 1.7. Can I cheat? I will cheat. I'm going to cheat. I'm not going to visualize. I'm just going to jump straight into the calculation. Okay, so for 1.7, less than, so this is what we're going to do. Less than will be this column. Greater than equal than will be this column. And the average will be this column. All right, guys? Just so we can move things up. So 1.5 is out. 2.7 is out. We start with 1.7. So what are the sets for 1.7? Oh, this is why I can't cheat. It's going to take too much. Let me make this bigger over here. There we go. All right, so I just added some more columns. I'm trying to figure out a way to do this so that it is more or less. Let's try it. Less than 1.7. All right. All right, fine. All right, less than 1.7. Let's go. That's just Apple. All right, and for you, you'll be everybody else, I guess. So you'll be 1, 2. Those are the apples. You'll be everybody else. All right, so you're going to be one apple is less than 1.5. That's less than 1. Sorry, less than 1.7 is just 1.5. So we're done. And then greater than equal will be everything else. So that makes 1, 2, 4 apples. And I'm just summarizing at this point. 1 orange. And how many cherries? I'm sorry, that's 3 apples. I double counted one of the apples. And 1 orange. And 2 cherries. All right, done. Let's do the math. Oh, let's scooch this over. I actually need that space for my math. All right, so my math, I'm going to do apple is 1 minus 1, that's 0, easy. 3, 2, 1. Yeah, cheat a little bit, grab the formula from here, up here. Just for me to do less, right, typing. So this is going to be 1 minus 3 divided by 3, 2, 6. 3 divided by 6. 2 divided by 6. And 1 divided by 6. Yes, that's the orange. All right, excellent. And the average will be 0 plus, what is it, 7 again? Yep, 7 again. So 1 divided by 7, no, that's done, that's 0. And so that'll be 6 divided by 7 times whatever this guy is. And I got my average. Bam. Done. Alrighty. Done. That's 1.7. Let's do 1.8 now. So less than 1.8. That would now be 1.7. Cherry. And your apple. Okay. And now I have to do for the other ones 1.5, 1.7. All right. Okay. So that's going to be 2 apples now. All right. So it'll be basically the same thing, except I have 1 cherry. So I do apple, 2 apple. Oops. Orange. 1 orange. And now 1 cherry. All right. So the left side is going to be 1 divided by 2, 1 divided by 2. There's going to be 0.5. That's easy. You don't have to calculate that. And this side, I'm going to take the equation. Oops. And just manipulate it, so now it became 2. Now it became 5 values, 2, 1, 5. So this all becomes 5, 5, 5. And now it's going to be 2 divided by 5 for 2 apples, 1 orange. Already have that. Oh, hold on. 1, 2, 4 plus 2 is 6. I make a mistake somewhere. 1, 2, 1. Yeah, it's 5. Okay, cool. I'm right. I'm losing my mind. Okay, 2 apples. No, that's 4. What did I do? Oh, I'm sorry. It's still 3 apples. It's 3 divided by 5. Sorry. Let me change this, guys. It actually went to 1 cherry. This is still 3 apples. Sorry. Confusing you guys. Confusing myself as well. 3 divided by 5, 1 divided by 5 for an orange, 1 divided by 5 for a cherry. All right, now I just have to do this. And this is going to be now 2 divided by 7 times this plus 5 divided by 7 times that. That's already good. All right, we're moving now. All right, 1.9. Let's do 1.9 now. 1.9 becomes, so 1.9 will now be, oh, okay, 1.9 makes a huge dent. So now we have, remember, green's the test data. So 1.9, less than 1.9, we now have an apple, cherry, apple. Okay, I'm sorry, not a huge dent, but so now it's going to be apple, cherry, apple. So now it's 2 apples and a cherry. Move over. That's basically what happens. Because there's 3 values that are less than 1.9, 1.8, 1.7, 1.5. All right, so all we did was just add an apple to this side. So now this is going to be 1 cherry, more space, and 2 apples. All right, 1 cherry and 2 apples. And this, an apple drops from here. So now this is just, finally, this is actually 2 apples, 1 orange, 1 cherry. All right. So this will be, let me do the math here. Drop one of these. All right, it's going to be 1 divided by 3 minus 2 divided by 5 . Two divided by 3. 1 divided by 3 squared, 2 divided by 3, done. This side, now we are going to edit this. So now finally this becomes 2, 4. So this will be 2 divided by 4 minus 1 divided by 4 minus 1 divided by 4. Okay, now just change the weights. It's no longer 2 divided by 7. It's now 3 divided by 7. And this becomes 4 divided by 7. Bam. All right. 2 more to go, guys. So 2. What's less than 2? Apple, cherry, apple, apple. All right. So less than 2 is now this apple, this cherry, that apple, and now this apple. All right. So now it's going to be 1, 2, 3 apples and 1 cherry. 3 apples and 1 cherry. Three apples, 1 cherry. And so now this guy becomes right here. This now becomes 1 apple, 1 orange, and 1 cherry. All right? Apple, apple, apple. Yep, that's right. Okay. All right, finally the left side has gotten bigger. All right, so let's go and copy this. So now this becomes 1 divided by 4. This becomes 3 divided by 4. All right, and this side now simply becomes 1 divided by 3, 1 divided by 3, and 1 divided by 3. Copy that over. And this now becomes 4 divided by 7. All right, finally 2.1. 2.1, less than 2.1, what do we got? We got apple, we got cherry, all right? We got the apple, and looks like there's no changes. All right, less than 2.1. No, we got this cherry. I'm sorry, it's less than 2.1. All right, so less than 2.1. This guy, apple, cherry, apple, apple, cherry. So what we did is we got 1 more cherry. We got 1 more cherry now, guys. So now it's 2 cherries. And obviously greater than or equal to 2.1. It's going to be apple, orange, and that's it. Greater than or equal to 2.1 is just apple and orange at this point. So this one now fell. There's no longer a cherry here. 1 apple, 1 orange. Let's go ahead and copy this down. So now it's 2 divided by 5. And 3 divided by 5. And this one now becomes basically, this becomes 1.5. Just go ahead and do this. 1 divided by just 2.5 because I know it's 0.5. Why do I know it's 1.5? It's because basically minus 1 over squared, half squared, minus 1 half squared. Right, so that's 0.5. And now the math. 5 divided by 7 on the left side. 2 divided by 7 on the right side. And we have our final values. Finally! All right, we look at the averages. All right, guys, what has the smallest Gini? It is this value is 2.1. So 2.1 gives me a left node of cherries and apples. Thank God, ladies and gentlemen, I have a clear prediction, which is apple. All right, it's a clear prediction with apple. So any value less than 2.1 will give me an apple. Unfortunately, on the greater than equal side, I have one apple and one orange. Because I already have an apple on the left side, I'm going to cheat again, and I'm going to say anything greater than equal to 2.1 is orange, okay? So our model basically says less than 2.1, apple, greater than equal to 2.1 is orange, and yes, I'm cheating again. Apologies. All right, so let's go ahead and do our actual, remember our test data, these are actual results right here. And now let's do our predicted values. So less than 2 is less than 2.1. That's an apple. Cherry is less than 2.1. That's an apple. Oh boy. Orange 1.6 less than 2.1. That's an apple. And finally, apple, that is less than 2.1. As predicted, an apple. All right. Okay. Let's do our confusion matrix. It's not going to work out right, but it is what it is, people. All right, so apple, cherry, orange. So first one would be apple. So I have one actual apple. All right, let me type that in for you so you can see it. Alrighty, so let's do the actual apples. How many actual apples there are? 1. All right, and that was predicted correctly. Yay! All right, and that's it. None of the other apples were predicted incorrectly because there was only one apple. Cherry. How many actual cherries I have? I have 2 actual cherry, guys. I have 2 actual cherries, and both were incorrectly predicted to be apple. No cherry was accurately predicted. And finally, I come down here to orange. There was 1 actual orange, and it was predicted to be apple. 0, 0. Alrighty. Ladies and gents, let's run this back again. All right. So what is my baseline baseline error again? Remember last time was 4 divided by, I think we're going to use the original. No, we're not using the original. All right. So I take my training data. I have apple, apple, orange, cherry, apple, apple, cherry. Okay. So I have 1, 2, 3, 4 apples. Actually, let's do the error rate first. Sorry, I'm jumping all over the place. Let's do error rate first, just to keep it easy. It's right here in front of us. What's our error rate, guys? What's off the diagonal of this one and this one? So that's 3. 3 divided by the total amount of numbers is 4. So error rate is 3 divided by 4. All right, not looking good. My baseline error, I go back to my training data, which is the blue and orange. So I have 1, 2, 3, 4 apples. So it looks like apple is going to be king here. So my error rate then is going to be, apple is going to be the prediction for this model. So I have orange, cherry, 1, 2, 3. So 3 divided by 7, my 7 is going to be my root error. All right, now to get my relative error, I divide one by the other. All right, so 3/4 divided by 3/7, that is actually easy. That becomes 4/7. So that's my relative error. All right, that was an easy one. Was it? Hold up. No, sorry. It's 7/4. I'm sorry, guys. 3 divided by 4 divided by 3 divided by 7. Yeah, that's 7 divided by 4. Notice again, that's a number greater than 1. All right. I got my error, relative error. All right, ladies and gentlemen, we are finally on the last one. Make that bigger. All right. Let me copy and paste this again. And now on this last one, orange will be the test data. Right? Orange will be the test data. Orange is test data. All right, let's do this again. So our training data is these guys, the blue and orange. I don't know why I did this. All right. So let's play like last time. Let's get our unique values, which is going to be, looks like our smallest one is 1.5 again. And then it's 1.6, 1.7, 1.8. Oh boy, here we go. Then we jump to 2, 2.1, 2.7. All right. All right. 1.5, 1.6, 1.7, 1.8. There is no 1.9. We jump to 2. And then we go to 2.1, 2.7. All right. So we'll knock out 1.5 and 2.7. All right. They're out. We're not going to do those two. So we're going to do these guys, 1.6 to 2.1. Again, how do I do this? I did greater than, equal to, I'm sorry, less than. Less than. That's the symbols I used. All right, same thing with these guys. Let's play, guys. Less than 1.6. What's less than 1.6? It's just 1.5. So we just have one cherry up in here. And everything else is going to be 1, 2, 3 apples. 1, 2, 2 orange. And 1, 2, 3, 2 cherries. All right, so for a total of 5, 2, 7, 8, 8. Because this training data actually has 8 instead of like the previous ones that had 7. All right, so this is going to be 0, done. This one, let me go ahead and grab nifty little formula right here. Yes, I'm cheating. I know, guys. I know. And so there are 7 on this side. So there's 3 divided by 7 for the apples. There's going to be 2 divided by 7 for the oranges. And there's going to be 2 divided by 7 for cherries. Boom. All right, now I'm going to go ahead and cheat again. Grab that formula. One divided by 8. 2 divided by 8. Bam. Is that right? That's low as heck. Oh, yeah, because it's not 2 divided by 8. I'm sorry, it's 7 divided by 8. Where's my head? So left side is 1 divided by 8. Right side is 7 divided by 8. Yeah, that's much better. Okay, 1.7, guys. What's less than 1.7? That would be your 1.5, 1.6, and that is it. That's cherry and orange. So now I have one cherry and one orange. That means here we lost an orange. Okay. This is 0.5. I'll cheat. And this is 3 apples, 3 divided by 6. 1 orange, 1 divided by 6. And 2 cherries, 2 divided by 6. Come here. Now this becomes, the left side becomes 2 divided by 8. The right side becomes 6 divided by 8. Bam. All right. 1.8. What's less than 1.8? It's now cherry. It's now going to be cherry, that cherry, and this orange. All right. So I gained one more cherry. So now it's 2 cherries. Yep. Just confirming that. And on this side, we lost a cherry. So now it's 1 cherry. Cheat. So now I have 1 divided by 3 minus 2 divided by 3. All right. So 1 orange, 2 cherries. Let's just keep it. 2 divided by 3, 2 cherries, 1 orange. I just want to reverse this so it's in order. And now this. Three divided by 5. 1 divided by 5. And 1 divided by 5. Boom. All right, now less than 2. Less than 2 will give me apple, cherry, cherry, orange. Okay, so less than 2 now, we've picked up apple. We picked up an apple. So I have apple, cherry, cherry, orange. All right, so now we have 2 cherry, 1 orange, and 1 apple. And on this side, we lost an apple. 2 apples. So now I have 2 divided by 4, actually. 1 divided by 4. And now I have to add another 1 for apple. 1 divided by 4. Now it's 1, 2, 4. 2 divided by 4, 2 apples. Two divided by 4 from 2 apples, 1 divided by 4 from 1 orange, 1 divided by 4 from 1 cherry. Bam, let's copy it over. Oh, okay, they're both the same. That was easy. It should be 4 divided by 8. Let's just keep this proper. finally, 2.1. We're almost there, guys, with this question. Wow. All right, 2.1. So less than 2.1, I'm just going to cheat. Greater than equal to 2.1 is what? I'll do this side. So greater than equal to 2.1 is going to be apple, orange, and that's it. Greater than equal to 2.1 is apple and orange. Yeah, right here. This apple, that orange. And that's it. That's the only one's greater than equal to 2.1. So in this one shot, I'm now one apple and one orange. That means everybody else goes on this side. So now it becomes 3 cherries, one orange still there. That cherry got gone, and there's one more apple here and 2 apples. So 3 cherries, 1 orange, and 2 apples. All right. And this one basically becomes 3 divided by 6, 1 divided by 6, 2 divided by 6. This is 0.5. And almost there. This is going to be 6 divided by 8. And this is going to be 2 divided by 8. All right. Now, guys, here. Which one has the smallest Gini score? That would be this guy right here, 1.8. All right, so 1.8 has the smallest Gini score. All right, so that's it. It's 1.8. So my left node, yes, I have a majority. It'll be cherry. Anything less than 1.8, it's cherry. Yes. Anything greater than equal to 1.8? Yes, I have a majority. It's apple. Thank God, finally. All right, so let's go ahead and do my... So less than 1.8, cherry, greater than equal to 1.8, apple. Cherry and apple. All right, so let's go ahead and get my actual values. So now orange is the test data. This is the actual values. We do that here. And now our predicted values. All right, 1.5, that is less than 1.8. You are a cherry, sir. 1.9, that is greater than 1.8. You, sir, are an apple. 2, that is also greater than 1.8, and you're predicted to be an apple. All right, we do a confusion matrix. Just copy and paste this. All right, so our first one, apple. So in actuality, we have 2 apples. The first one is mischaracterized as cherry. And the second one is correctly predicted. Yes, excellent. And we don't have any oranges. And we have 1 cherry that is incorrectly predicted as apple. All right, and then we're done. What is my error rate? It is 2 divided by 3 again. What is my root error? In this case, let's see, we have 8 values. 3 of them are apple. Oh God, we have that problem again. 2 of orange and 3 are cherry. So, it doesn't really matter at this point. Apple, cherry. So what matters is that the incorrect answer is 4 divided by 7. Oh, no. It's 4 divided by 8. No. Hold on. 1, 2, 3. 3 apples. 3 oranges. Okay, yes, that's right. So whether it's cherry or apple, the incorrect answers are going to be 5 divided by 8. So 3 of the labels are correctly, whether it's apple or cherry, 3 of them are correct. The other 5 are incorrect. So our root error here is now 5 divided by 8. Oops. All right, now our relative error, it's what? It's our error rate divided by root error. I can't do this in my head. So I'm literally going to do 2 divided by 3 divided by 5 divided by 8 for 1.06. Is that right? 2 divided by 3, right? Divided by root error of 5 divided by 8. All right, excellent. That's 1.03. All right. Now, guys, what is our X error, cross-validation error? It's going to be the average. So let me get my 3 numbers. Oops. So let me give me my 3 values. This was the first one. This was the second one. That was clean. And this was my last one, my 3K full test. All right. So what is the X error? Let me slide these numbers over. All right. So X error is the average of these ones. Average of these 3 numbers, which is 1.37. All right, that's my X error, guys. So what's my STD? This is going to be my standard deviation. So my STD is 0.369. Bam! That is the answer when you're doing K-fold. That is painful. And we just did a 3-fold one. Imagine a 10-fold one. All right? And this is why we use our part, guys. This is why we have all these libraries at our fingertips. Once you understand it, go nuts with those libraries. All right? So that would be number 2. Finally, number 3. All right? And you guys were wondering, why did I put just 3 questions? This shouldn't be that bad. Given the trading data, I used the same trading data, thank God. And loss matrix below, this loss matrix. Calculate the Gini impurity score and the splitting value for the first split value. All right, so I want to create the first split value. But now I'm going to use the loss value. So now I have to actually do both columns here, guys. Now I have to do both columns. But I say assume min bucket 3. All right, we're assuming a min bucket of 3, so that's going to come into play. That'll make my life a little bit easier. So this one we'll do right. We'll look at both columns. I'm going to do this right, guys. All right, here we go.